Hello everyone and welcome back. In today's video we're going to explore a topic that is often overlooked but super important in precision engineering, and that is relief grooves, especially type F, G, D and E, both internal and external. Whether you're designing a shaft, bore or assembly that includes mating parts like bearings, gears or seals, understanding relief grooves is key to better functionality, longer life and easier manufacturing. So let's get started. What a relief groove is. A relief groove is a small machined recess or groove added to a part, usually shaft or bore, typically at the transition point between two surfaces. Think of it as a stress relieving or tool relieving feature. It allows you to smooth corner transitions. It also allows you to do clearance for tool run out during machining. It reduces stress concentrations and it gives you better fitment of mating components like bearing seals, retaining rings, etc. Without the relief groove, sharp corners can create stress risers, leading to cracks or failures. They can interfere with mating parts or even cause poor setting for critical components. So, this was very short introduction about what the relief groove is. Now let's talk about why is it so important and why we should include them in our components. So first of all, it is very important for machining tolerance, since relief grooves give tool space to exit smoothly without leaving burrs or undercuts. Second of all, assembly fit. They allow components like bearings, bushings, circlips or seals to sit flat against the shoulder. Moreover, they can reduce the stress. Rounded or chamfered grooves reduce stress concentrations that occur at sharp transitions. Last but not least, improved longevity. Mechanical systems experience less wear and fewer premature failures. In summary, a simple groove can save you a lot of trouble, guys, really, both in manufacturing and in real-world use. So, we already know what the relief groove is, why is it so important. Now let's talk about each type of relief groove separately. Let's start with type F. Type F groove is commonly used at the end of a shaft or inside a bore right before a shoulder. We have two types of F groove, internal and external. External shaft is used where a component like bearing or spacer needs to sit flush with the shaft shoulder. On the other hand, the internal one, which is also called bore, is mostly used in a housing to allow a component to set against the shoulder inside. It features a radial groove with a relatively deep and narrow profile, providing tool run-out space and sitting clearance. This type of relief groove is ideal for axial fixing of rings, gears or seals. It's mostly used for bearing seats on shafts or seal installation on internal bores. Another type, type G. This is a wider and more rounded groove than type F. It is especially used when you want to avoid sharp corners entirely. We have again two types of it, external and internal. External is ideal where the mating part might not be a perfect fit and needs more tolerance. On the other hand, internal prevents interference with internal snap rings, washers or deep-seated seals. It has many advantages. I will mention just few of them. For example, smooth tool exit during turning or boring, better for components that move along the shaft or bore. It also helps in pressure seal application. You should always use type G when you need a gentler stress transition or wider radial clearance. Now, let's talk about type D. Type D groove is more of a chamfered or undercut groove, commonly used in shoulder transitions. External one is found at the base of a stepped shaft where the diameter suddenly drops. Internal can be found at the end of a shoulder inside a hole. There are some very important characteristics which are characteristics only for the type D, such as They are typically shallow and angular. They offer minimal material removal, just enough for a clean edge. They also helps tools complete the machining pass without chatter or burrs. You should use this type of groove only when you need minimal axial play, when you want to keep wall thickness intact, or you require tight axial tolerance. Finally, we have a type E groove. Type E relief groove, a more specific groove usually associated with snap ring or circlips grooves, often comes with a special profile, sometimes semicircular or rectangular, locating next to a groove for retaining components. External is on shafts. It helps rings fit properly without interference. Internals are in bores. It offers clearance for circlips, allowing easy assembly or disassembly. Use this groove when your component relies on axial retention with circlips, snap rings, or similar locking feature. Don't confuse this with the actual retaining groove. It's the relief groove beside the retention groove that ensures proper setting and clearance. So that was basically it about different types of relief groove, and now let's see how you can use it in drawings and how you can mark it specifically each type of relief groove. In conclusion, I just told you the most important facts about each type of relief groove, and now let's see what is the most important information what you should take home for. In conclusion, I just explained you guys what different types of relief groups are and how you can use it. Now your take-home message is: use type F for general purpose tool clearance and setting, type G for smoother transitions and when more tolerance is needed, type D when minimal space is available but relief is still needed, and use type E for circlips, snaps, rings, assembles when precision fit and clearance are critical. Also, another take-home message from this entire topic is: when designing parts, always check if the mating components needs full face contact. You have to be very careful how you choose the right groove based on function, which is clearance, stress reduction, or component retention, and you have to follow standard dimensions from DIN 509 ISO or manufacturer specs. Just one small relief groove can make a huge difference in performance, durability, and manufacturability. So that was it for today's topic, guys. Thank you very much for watching. If you found this video helpful, don't forget to like, subscribe, and comment below which groove you use most in your designs. Stay tuned for more mechanical design tips and deep dives right here on my channel.